First thing we want to do today is to go through the different naming things that you guys did. Let's take a look at that page of the acid base stuff. That's better. So let's go down through here and finish these off. Taking a look and checking your answers as I go down through. Here we have hydrofluoric acid, so that would be fluoride, which is F. On the periodic table of elements, F has a -1 charge. So that means we will get 1 H. Here we have phosphorus acid. Phosphorus. What does OUS lead to? Ide, ate, or ite. Us. Ide, ate, or ite. Players at home can play along. Ite. So phosphorus, we're looking for phosphite. If we look on the back of our periodic table at these polyatomic ions, if you don't have those memorized, right? You're gonna need your periodic tables, right? Phosphate is PO4, 3 negative. Phosphite is PO3, 3 negative. So ite is PO3. 3 negative means we need 3 hydrogens to cancel that charge out. Remember, each hydrogen is a H plus. So we need 3 H pluses to combat 3 negative. Then we have HBr, so that's bromide. So that becomes bromic. And since there is no oxygen here, that is hydrobromic acid. H2S, that's sulfide. So it becomes sulfuric. No oxygen means we have a hydro there. NO2. Finding NO2 on our periodic table. That is nitrite. So we take nit and ite becomes us. So nitrite becomes nitrous acid. If you don't know the polyatomic ions and stuff like that, that's going to make you slower. But yeah, all of this is all coming together at this point. Here we have SROH. So that is SR is strontium. From knowing the symbols from last semester. Finding strontium on your periodic table, we find that strontium is in group 2A. The fact that it is in group 2A means that it does not need Roman numerals. Because 1A, 2A, and silver, zinc, and aluminum all have a set charge. So this will be strontium hydroxide. Here we have K. Does anybody know what K is? Very good. Potassium. Didn't have to look it up. Is potassium in group 1A, 2A, silver, zinc, or aluminum? Group 1, right? So that is potassium hydroxide. No Roman numeral needed. How about BA? Barium, Landon says. Anita is correct. So that is barium. Is it in group 1A, 2A, silver, zinc, or aluminum, Landon? Barium is actually in It's in 2A, right? So we don't need the Roman numeral for that. HClO3. So we have that ClO3. We got to look on the back here. Here, right here is ClO3. That is chlorate. So that ends in 8. Chlorate becomes chloric. Since there is an oxygen, there is no hydro. So that is simply chloric acid. LiOH. So we should be to the pattern now that knowing this is something hydroxide. What is Li? Lithium. H3PO3. So PO3 is phosphorus. So that's going to become, phosphite. That's going to become phosphorus. My mind was working ahead. And that's going to become phosphorus acid. It becomes us. Check the rest of the answers there. And I will be right back in 1 second. So here we have some formulas. Take a look. Yeah, we did this. Cool. It looks like we did this last week. We talked about how pH equals the negative log of the hydrogen ion concentration. So you're going to want to get a nice calculator out. If you don't have one in here, you can get a TI-30X2S off the wall over there. Those at home, you want to get a calculator out. So if we take a look, pH is equal to the negative log of the hydrogen ion concentration. pH plus POH has to equal 14. If you recall, 7 is neutral. POH is equal to the negative log of the hydroxide ion concentration. And then there's one last thing. If we have the pH, we can go to the hydrogen ion concentration. And that's something that you guys all grabbed in the laboratory yesterday, right? So out of each of these, for the Sprite, the vinegar, the bleach, what is the best measure of pH, do you think? The pH meter. Now, the universal test strip is fun. And the cabbage is cool to see. But the best reading for these is the pH meter. The pH meter gives it out to 2 decimal places. Very nice. So what we are going to do is we are going to find the hydrogen ion concentration using the information from the pH meter. Where's my calculator? You got one of these fancy calculators, that's fine. Let me grab one of the smaller ones too to make sure everybody knows how to use all of this. Where's my watermelon calculator at? Huh. I'm gonna grab one. You don't have one, they're on the wall over there. We good? All right. So one of these, either of these will be fine, doesn't matter which color. But on here, we've got the pH, and we want to get the hydrogen ion concentration. So we will go from pH, we'll take 10 to the negative pH, and that will be the hydrogen ion concentration. So the button for that is known as the antilog. You can see it right here. On this calculator, we would hit second, and that would bring up this right here. And then it's 3.94. So we would hit negative 3.94. Boom. And that is the hydrogen ion concentration for Sprite. Be careful, I write it in for you. All right. So I have 3 digits here, right? So I'm going to use 3 here. 1.15 times 10 to the negative 4th. 1.15 times 10 to the negative 4th. Now that is concentration, so that is molarity. So remember, I used a 4-corner diagram and I went from here to here. The next one says the hydroxide ion concentration. So now I'm here and I want to go to here. So what do I need to do? I need to follow that top arrow. And I'm going to take 1 times 10 to the negative 14th, and I'm going to divide it by that answer. That's going to give me 8.7 times 10 to the negative 8.71 times 10 to the negative 11. And that again is also molarity. So that's the hydrogen ion concentration, and that is the hydroxide ion concentration there. I'm sorry? Yeah, 1 times 10 to the negative 14th How do I do that? And then you divide by the hydrogen ion concentration, which is right here. That's the hydrogen ion concentration. Yep. So let's do vinegar. This time I'm going to do it with the other calculator. So again, if we take a look, we have 3.5 for the pH. So we hit the anti-log button, and for these calculators, it is the second function of the log. And then we have negative 3.5. Enter. That is 3.16 times 10 to the negative fourth. Then we will take 1 times 10 to the negative 14th. We will divide that by that, and we will get 3.16 times 10 to the negative 11. Yeah, give me 1 second. All right. Questions on that? All right, I'm going to let you guys go into your, let's take a look at the rest of that real quick. Let's see, here's again. One. So if we take a look here, last thing we need to do on this data, this database right here, is we need to fill in whether it's acid, base, or neutral. So what you can do is you can look at the pH, and if it's, what makes it an acid? If it is above or below what? For an acid. Yeah, it has to be below 7 though for an acid, right? So acids, the pH is less than 7. A base has a pH greater than 7. So is this an acid or base, right? Acid. We can just put an A in there. How about bleach? That's a base. You would go down through and do all of those different things. I think there's some questions on here. And then there's a little lab quiz that you'll want to finish here. So you want to recheck this, right? And then you can go down through and finish those questions, and then you can submit that through the end of it. You can submit that through Canvas if you would. Give me 1 second. So you were to go through here and do all of these different types of problems. I'm going to go through and do one of each type again, give you another day, and then tomorrow when you come in, we'll go through the answers for these. So this all runs from the 4-corner diagram that we've been working with. Let's take a look here. So if we have 1 times 10 to the negative third, the negative log of that, you guys have probably had logs in your algebra class. The negative log of that is actually just 3, right? Let's take a look here. Here's 2.2 times 10 to the negative fourth. So I know that that's 2.2. This is negative fourth. So it's going to probably be 3 point something something. So let's put it in the calculator. Negative log. We're going from the hydrogen ion concentration to the pH. Let's take the negative log of 2.2 times 10 to the negative fourth. If we take a look, as we said, it's going to be, if it were 1, it's equal to that exponent, the negative of that exponent, I should say. Since it is a number and then times 10 to the negative fourth, it's going to be 1 less than that exponent, that negative exponent. So it's going to be 3.66. So what do you think about this one? 7.8 times 10 to the negative 12th. It's going to be what? Without typing it in. It's not going to be 12. It's going to be what? Man. Anyone? What was this one? This is negative fourth, and it was 3 point something, right? So if this is negative 12, it's going to be what? 11 point something, right? So we hit enter, we got to put it in, and then we get 11.11. So that's what negative log means. Basically, you take that exponent and it's based off of that. When it's just 1 times 10 to the negative something, then it is just equal to, negative log would be equal to that exponent. But when you have a number that is different than that, you actually have to fill it out. You actually have to fill it out. In reality, this is 5 times 10 to the negative 1, right? So what do we expect? Well, negative log 0.5. We're going to get something less than 1. Well, we get 0.3. If the pH is 3, is it an acid or a base? Acid. If pH is 0.3, is it an acid or a base? Acid. If the pH is 11, it's an acid or a base? Base. Right? So you can go down through there and play all of those different games. The next one says, if the pH, determine the pH if the OH is this. Well, remember, that's a different thing. We've got OH up here. Well, we can take the negative log of that and get the POH, and then we can subtract that from 14 to get the pH. So, easy enough. Well, this would be 11. POH would be 11. So pH, what's 14 minus 11? 3. Right? Again, negative log, we know it's going to be 2 point something, 4.3 times 10 to the negative third. So 2.37. We're going to take 14 minus that. We get 1.16. And you just go down through there doing that, following that box, that 4-corner box. Yep. Here it says determine the pH if the hydroxide ion concentration is this. Well, this is checking your vocabulary. You need to know that hydroxide means OH. So it's the same thing. We're going to take the negative log of this. What's the negative log of 1 times 10 to the negative 9? 9, right? What is the negative log of 2.3 times 10 to the negative 7? It's going to be something point, like what point? It's going to be 6 point something, right? So we actually need to write that in, negative log 2.3 times 10 to the negative 7. So we get 6.64. So the key here is knowing where you're at, starting out on this 4-corner, and knowing where you're stopping. The last problem, we were stopping here. This problem, we're stopping short here. It says determine the POH if the pH is this. Well, 14 minus pH equals POH. That's from the 4-corner diagram here. 14 minus pH equals POH. So 14 minus 3.2.
The answer is 10.8.
10.8. 14 minus 1. 13. Those are very easy. Determine if the solutions in 4 are acidic or basic. Determine if they're acidic or basic. Well, pH is greater than 7, so it is base. pH is greater than 7, so it is base, right? And then this page right here is doing the same thing. This is one that you just did from the laboratory. This times this has to equal 10 to the 14th. So if we take 10 to the negative, 10 to the negative 14, 10 to the negative 14, and we divide it by this, we get the hydrogen ion concentration. 5.62 times 10 to the negative 14. over and over and over again. Determine the pH, and this time they're being a little more sneaky. They're giving you each a specific thing. So you got to follow the four-corner diagram. Then it says determine the hydrogen ion concentration, and again, they're giving you different things. So you got to follow the diagram. Determine the hydroxide, giving you different things. So you got to follow the diagram. That laboratory is due Friday. Make sure you do get the quiz done. I don't care so much about the pre-lab, but by Friday, that laboratory is due. I want these done by tomorrow. We'll pop the answers up so that you can see them, and then we will move forward with acid base. After that, we got about 5 minutes. If you have questions, by all means, stick around. All of the credit recovery work has been graded and put in there. You may want to check your grades on that and see where you're at. And if you weren't here yesterday, we talked about how instead of a final exam, we're going to end up having our final test be optional. That final test that will be taken during the final exam time is an exam over acid-base chemistry. Acid-base chemistry does include things from the past, though. So make sure that you understand that. For example, if I have a higher concentration of acid, will the reaction occur faster or slower? Faster. What if I take a big hunk of metal and drop it into an HCl versus I shave up the metal and drop it into HCl? Which metal will react faster? The shaved metal, right? So all of that stuff is still applicable, but it's mainly going to focus on acid-base chemistry. So that's all I got. If you got questions, by all means, stick around. Otherwise, have a great day.